Hi guys, this is Abhijit from Smart AI Technology, and today we are going to analyze a dataset called the Heart Disease Dataset from Kaggle. The link is present in the description. You can go through it. Now, let's get straight into the notebook. Now, what we are going to do here is, first of all, we are going to import the dataset. Now, Kaggle provides us the default code for inputting any kind of dataset. So this was already presented in the Kaggle notebook. Now what I did was this provides us the path of the data set. So what I did was, as some of the columns were not that comprehensive and it were a little bit confusing. So you can see it here, like the chest pain is termed as CP. The resting blood pressure is termed as T-rest BPS. Cholesterol is termed as CHOL. That is a bit understandable, but still. Um, let's move forward. Now this one I don't understand what it is. So what I did was I went to the UCI machine learning repository where you can find the same data set, but here all the columns are explained properly. Like what is THALC, and it is explained here properly. Like is a 32nd number row, which is maximum heart rate achieved. Okay, so which I termed as maximum pulse. Here you can see I changed the name to maximum pulse. Similarly, many other columns that were not very understandable in the data set, I changed the name using this columns list, and I used it as names while inserting the data set. Now the data set is stored in the variable data, and after executing this cell, the data.head gives us an output as shown in this following table. Now we can see that columns like resting ECG, angina, slope, major vessels, THL, THAL, that we are getting values like 0, 1, 3, and we don't know what this means. So I've added an extra text section here after the output to get a brief explanation about what these values mean. Moving on to the next cell, I wanted to check what all unique values the columns are having, so I printed them using a for loop. As it was a very small dataset of around 1000 rows, it was not big of a deal, but had it been a very huge dataset of millions of rows, printing the unique values wouldn't help that much. These unique values also helped me determine which plot to decide for a particular attribute. Now I want to know whether any data cleansing is required for our dataset or not. So for that, what I'll do is I'll use the isNull function to check if any null values is present in our dataset or not. And with that, I'll use the sum function to get the sum of all the null values. So here I can see in the result that we do not have any null values currently present in our dataset. So the data cleansing is not required for now. Diving directly into the data analysis, firstly importing the main libraries that are cbot and pyplot from matplotlib, and then finding the correlation of all the attributes that are present in the dataset using the heat map. Here we can see that the dark blue color represents the positive relation among all the attributes, and the bright yellow color represents the negative relation. And for the, let's say for the target attribute, we can see that chest pain, max pulse, and slope contributes the most, as they are the dark blue ones in the in this row. So moving further, using pair plot, what we are doing is we want to see we want to see relations between every pair of attributes that are present in the data set. Basically, it generates a scatter plot or other plots that are present in Seaborn um, document. You can see it can also plot KDE and other types of plots. Keeping it aside, we can see here that we have plotted these scatter plots between all the attributes. We can see that most of the plots that have value more than 3 or 4, they are like overlapping. So here, if I zoom it into it, we can see that age and chest pain. Like chest pain has only 4 values. So age and chest pain, we cannot like properly determine what kind of plot and how the data are distributed in it. So it does not give us that clarity. We have other plots that represent the relation between these kind of attributes. We have it in a further code. So let's move on. So now what we are going to do is analyzing attributes with respect to the target value. So let's get on. We are now analyzing max pulse with respect to the target value. Let's see what we get. Here what we get is, you can see that this portion, this whole portion, this represents the population that has the target as 1, which means that the people lying in this portion are having the heart disease, but people lying in this portion are not having the heart disease. We cannot predict, we can predict, and there is a 50-50% chance for people that are in this region, like the grayed out region. Similarly, we can plot the other attributes with respect to the target. Let's see what we have plot. We have plot the cholesterol with respect to the target. We have plot the resting ECG, the angina, and old peak, and the thal attribute. Let's see what goes with the cholesterol one. Here we can see that most of the people that are present in the grayed out region are having both as uh, like both the patients of heart disease and those who are fit are present in these regions. But we can see that in the range of like 180 to 250, and with high count of cholesterol, they are having the heart disease. But as the cholesterol is getting, as the value of cholesterol is getting high, we can see that the heart present patients are also getting, the number of heart patients are also getting low. Here you can see that with the high cholesterol, 1 or 2 patients are here in this region. Proceeding forward with ECG, what we can see that there are 3 values of ECG, I guess 0, 1, and 2. So what we can see that with the value 1, people with the heart disease are present here. Most of the people with heart disease are present. But people are also present in zero section as well. But the people with those who are not having the heart disease are more here. And the opposite case is in this one section. Okay, let's go with the angina part. We can see that people are having heart disease. Those who are having angina is 0, and people are not having heart disease. Those who are having angina as 1. Moving forward, for old peak, what we can see that people those who are having old peak as 0 or around one or less are having most of the heart disease. But as the old peak is increasing, the heart disease, patient with the number of heart disease are getting reduced. So this has an inverse relation with heart disease. Now coming back to the thalassemia part, which is the thal attribute, we can see that people those who are having the thal value as 2 are having most of the heart disease. And the positive part of this hist plot is that we can see how the graph is varying with respect to the data points present in the graph. So we can see that the sudden increase in the peak of this graph, which represents most of the patients with heart disease, are present in this area. Now moving forward, now here what we have done is we have done the same histogram plot, but here we have used count plot. What we have done is we have shown the gender count based on the heart disease. Here we can see that 1 is male and 0 is female. Most of the female are having heart disease with respect to the male, as most of the male are not having the heart disease. Moving forward with the same um plotting technique, what we have plotted is chest pain versus heart disease. The chest pain for the value 0, what we can see that most of the people lying in this zone are not having the heart disease. And the opposite case is in the value 2, most of the people are having the heart disease, which are having chest pain value as 2. Now coming to the age count on basis of heart disease, we can see that from the range 41 to the range 54, what we can see is people lying in these age group are having most of the heart disease. The peak has reduced to some extent, but still again it got up, and again the peak of people having heart disease are getting down. You can see that the trend is getting down. Okay, moving forward, now what we are going to plot is we are going to relate any two attributes with respect to the target. Like we are using line plot here to plot the we are comparing age and chest pain here with respect to the where it is. Yeah, okay, no, we are plotting we are comparing two attributes here. Here we are comparing age and chest pain. Again, similarly, we have done two more graphs, which are we are comparing age and resting BP. How resting BP is varying with respect to age, how chest pain is varying with respect to age, and how cholesterol is varying with respect to age. We can see here that this blue line is for females, and and the orange line is for the males. We can see that for the age 30 to 40, the peak is very high. Like the chest pain for the people having age group of 30 to 40 are having huge chest pain. But as the age increases, the trend becomes stable, and then again it increases for the male. But the same is for the female. But what we can see here is that it does not increases that much with that much as compared to the male. But at the end, like from 65 to like 75 age group, the peak is even more than the male. Now moving forward, what we can see for the resting BP is that it increases with age for both male and female. But in case of female, we can see that the resting BP increases drastically. Moving forward, again with cholesterol, we can see the same trend that with the increase of age, the cholesterol is also increasing. Again, the same case is for the female. The cholesterol is increasing, but it is more than male. Moving forward, what we have plotted here is we have plotted the same line plot, and we have compared the max pulse with respect to the slope, and taking HUE as the target. What we can see here is that, yeah, what we can see here is that max pulse first decreases and then again increases as the target value, which is one for the population that are having the heart disease, are having pulse more than the people that are not having heart disease. Here we can see the same trend for both the heart disease and people with the heart disease and people who are not having the heart disease. But the maximum pulse for people which are having heart disease are more than the people that are not having heart disease. Moving forward, what we have plotted here is we have plotted a rel plot that shows the variation of max pulse with respect to resting BP, and the size of this circles we have taken as cholesterol, like how max pulse is varying with resting BP, and what is the value of cholesterol for each data point. We can see that even with less resting BP, we can see that max pulse is very high, and people present in this group are mostly having heart disease. So even if the resting BP is low and the pulse is high, we can see that the people can have heart disease. Now moving forward, we have plotted a violin plot here. As we can see that in the pair plot, what we saw that this does not represent much, as most of the data points are like on in the same line, and we do not have that much clarity what is going on. So what I did was I took the help of violin plot and I plotted. So what we can see is that with respect to thalassemia, the resting BP is kind of average, but as the thalassemia value increases, we can see that the resting BP decreases for the people having heart disease. For thalassemia 1, we can see that here most of the population with heart disease are there, and the trend is decreasing. For 0, we don't have any population. Like there were very minimum population with heart disease. So, but as the value increased of the thalassemia, the population also increased. But uh, then again, with increase in the value of thalassemia, the population went down for the people having heart disease. Similarly, as we used violin plot here, we used joint plot to plot the relation between thalassemia and old peak with respect to the target. We can see that people having thalassemia value as 2 and old peak value around 0 to 2 are mostly having heart disease here. Like you can see the peak here, the orange line's peak. The orange line here describes the people having heart disease, and the blue line describes the for the people that are not having heart disease. Here also you can see that for the value 2 and thalassemia value 2, and for the old peak value which is 0 to 2, we can see that people those who are present here are having the heart disease. Similarly, what we have plotted is we have plotted major vessels versus the max pulse with respect to the target. Let's see. What we can see here is that for the major vessel having value from -1 from -1 to like 1.5 or 2, let's say 2, and the max pulse between let's say 130 to 200, people present in this area are having most of the heart disease. So, yep, that's all for this data set. Thank you all. And if you like this data set, please upvote it and please subscribe to the channel. Thank you.